In this video, we will go over the fighter script that is attached to the enemy scene. So this is fighter.gd. At the top we have all the scenes and scripts that are related and used in this script. We use the Y framework. The bullet is not used. We will need to use the explosion scene when the fighter is destroyed, and the main weapon to handle all the weapon functionalities. The enemy pointer does not exist, but it refers to the target tracker, the thing that appears at the side of the screen when the player doesn't see the fighters. So the random generator is used when the ship needs to move to a random position, so this is how we generate the random numbers. Max HP is the maximum hull the ship has. HP is the current ship hull. When it reaches 0 or below, the ship is destroyed. The ship also has shields. This is the maximum shields, and this is the current shields it has. When it's lower than the maximum shields, it will regenerate the shield at the rate of 2 seconds. That's why we need a timer here for the shield. So when it's damaged, it will regenerate every 2 seconds. This is the ship's speed. For now it doesn't change its speed, it will always move at this speed. This is the ship's rotation speed, how fast it rotates. We will use it for the steering behavior, and this is the ship's velocity. Its speed plus its forward vector, basically. That's the old target the ship was targeting, and that is the current target, the object it's targeting now, be it another ship, a fighter, a turret, whatever. Random target is a position, a 3D position. It's a vector tree. It represents a 3D position the ship needs to move to when it's in the move random state. When it reaches that position, this flag, random target reached, will be true. When it's dead, this flag will be true. And dead. So in state, it's basically the movement AI. It has 2 states: move randomly and chase the target. Move random moves to a random position anywhere around the target, and when it reaches it, it chases the target. You'll see in a moment. The team is basically the friend-foe indicator. If another object checks this object, it checks if they're on the same. It can check if they're on the same team by checking its team. Like if it's team 2, and it checks if it equals to this team. Yes, 2 equals to 2, so they're on the same team. If it's on team 1, the player's team, so it will regard this object as an enemy. So yeah, team is basically the friend-foe indicator, and used for other stuff too. You'll see in a moment. Modal is the 3D model. It's this of the fighter. In its init function, we first add it to the enemy group. This will change in the future, and we init the weapon. We pass to it this object as a reference, so it can reference this object, and this is the fire rate of the weapon. If it's team 1, we create a new material, and its color will be team 1's color. Like that's team 1's color here. So it will change it from red to team 1's color by setting the models using set surface material to the new material we created with its albedo color. So material, it's actually the 4th material, but it starts counting from 0. I'll show you. So surface 1, 2, 3, and 4. This is what we want to change. We want to change its albedo, let's say, to this color. So as you can see, it counts from 0 to 3. So surface 1 is 0, surface 2 is 1, 2, and surface 4 is 3. So that's why we put 3 here. And we also modulate the target tracker sprite to green. This is RGB, it's in RPG format. Red is 0, green is 1, and blue is 0. So we're talking about this sprite. If it's an ally, the target indicator at the side of the screen when the player doesn't see the ally fighter will be green. So in the update method, the physics process, first thing we do is check if there isn't a target, set a target. And then we do the movement functionality, shoot functionality, and this shield do method handles the shield regeneration if the shield was damaged. Take damage is called by bullet. I covered it when I covered the bullet script. So if you saw it, or if you didn't see it and you want to know what it does, you need to see that video. Here we use explosion when the ship is dead. So let's look at set target. It has two parts. The first part is looking for an enemy player, a close enemy player by 300 points. And the second one searches for an AI fighter, another fighter, enemy fighter. So basically, if it finds a player, but then it finds another fighter, it will home first on enemy AI fighters. So let's look at it. We get all the players using get by type, and we get the player type. We check it's not null, and we check that the first object is not null. We put the first player we find in player target. We check if the player's team does not equals to our team, meaning he's an enemy, and we also make sure it's a valid target. In case the player was destroyed, the ship removed, or whatever, we must check it's a valid instance. So if it's not on the same team and it's a valid instance, check the distance between the player. We call YE distance 3D. It gets two objects, this object and the player object. And we check if the distance is smaller than 300, set the target to the player. Let's look at the distance. So YDist does all of this long chaining in like less than 2 words. And YDist VT checks the distance between an object and the vector. Here we pass a vector, and here when we get the object, we call its origin vector. So that's what this does. Look at slow is the same as look at, but it uses interpolation to change the rotation using the basis vectors. We change it by the rate of the rotation speed. So that way, when you use look at, it rotates instantly, but this rotates the object with a lerp, with interpolation. So we use that for the steering behavior. You'll see in a moment. So let's look at this. Here we get all the fighters. We shuffle them. So it will, every time you play the level, it will lock onto different fighters, not always the same ones. So we randomly shuffle them. It's a Godot function. So for each fighter, inside fighters, first we make sure it's a valid object. So if it's not valid, move on to the next one. And then we check the distance between this object, this fighter, and the current fighter in the loop. If it's less than 1000 and the fighter team is not equal to our team, meaning it's an enemy, set the target to the current fighter in the loop and stop the function with return. So that's how you set the target for now. If you look at the turret script, what it does, it takes the player and it adds it to the fighters and then shuffles it, the whole array. We might change this in the future if we need different AI behavior, but for now, that's what we have. In movement, first thing, this is legacy code, needs to be removed. It starts from here. we check two things: if target is not null and if it's a valid instance. Like if we got a fighter that was destroyed by mistake or something, we basically won't break the game. So movement has two states. If the state is move random, do all of this. If the state is chase, do all of this. And this is the actual action that moves the ship forward. So we move on the z basis, the forward vector, multiplied by the speed, and we add it to the origin vector using move and collide, multiplied by the delta, of course. So basically it will always move forward, doesn't matter how you rotate it. Like let's say you rotated it like here, it will move forward. If you rotate it like up, it will move forward. The forward vector will always be this, in front of the ship. So this saves us a lot of well, that's the only calculation we need to do. The rest of it is handled by look at slow. So let's see what it does. Move random. First thing it does is set a random target, and then move to that random target, rotate towards that random target, and it moves forward all the time. What it does, it rotates to the target, but if you're close to the target, mark target reached as true and change to the chase state. So basically it's very basic dogfight behavior. You move to some position, like you fly somewhere, and then you turn to face the enemy, chase it, shoot it a little bit. When you're close to the enemy, you don't collide with it. You again go to another random position, and when you reach it, you rotate back to the enemy to shoot it again. So it alternates between move to a random position, chase the enemy, move to a random position, chase the enemy. So let's go into more details. If random target is reached, like if you reached the target, or there is no random target, reset the target. So random target reached, set it to false, and get a new random target. Randomize the random generator and create a vector tree for the x, y, z position, basically in a range of minus 50 to 150 to positive 150 for the x, y, z, and then we get that random vector and add it to the objects vector. So let's say that's the target, right? So we have the target plus the random position, let's say here, or the random position can be here or here or here, like more like here or here because it's 150. So that's what it does basically. When you get a random position, you like get a random value and you add it to the position of the target. Like we're targeting this ship, add a random position here, move here, and then chase it until you get close to it, and then get a random target, move here, and then chase it again, move, I don't know, here again. It's random. So basically that's the behavior. That's what you see when the ships are fighting. Yeah, so now that we have a random target, check the distance between this object and the random target, get the distance, and if the distance is smaller than 40, like you're close to the target, like you basically you reached it when it's smaller than 40. So set the target reached to true and change the state to chase. If you haven't reached the target, try to move to it by, rotating to it and moving on the forward vector. It's so effective, I needed to write it only once, the script that does the movement. The only thing is moving the ship in the direction you want it, in the way you want it to behave, like move to a random target or chase. Chase is simpler. Get the distance between this object and the target, not the random target. The random target is just a point around the target. Let's say this is the target, that's the target position, that's, a random target here, or somewhere here. So basically here we wanna get the distance between this object and its here, and its target. And if it's smaller than 40, if you're too close, the enemy, or a fighter chases another fighter and it gets too close, they're not going to collide. You're going to move to another random position, and when you reach it, you'll chase again. And yeah, while you haven't gotten too close to the target you're chasing, look at it slowly, rotate slowly towards it, and that's what creates the steering behavior, basically. Artificial steering behavior. Basically rotate, look at slow. Yeah, here we don't need all these arguments, because fighter has its own look at slow function here, so it rotates from its transform basis, like all of them, to the target transform basis using interpolation. You see, the t basis y from the global transform basis y by the rate of the rotation speed, and it does this for all the basis vectors, the x, y, and z, the forward, up, and the side. I explained about it a little bit in the player script about the basis, the transform basis. Where were we? So yeah, that's basically what move does. That's the meat of this script, the movement behavior. The shield do and the shoot are much simpler. I'll cover them in 5 minutes in the next video. But this is the meat. Move to a random position, chase the target. And all it does is, the main thing it does is look at the random target around your target, a random position around the target, and it will move towards it using the forward vector multiplied by the speed. And when you reach it, when you reach the random target, change to chase, and now you're rotating to the actual target position. Yeah, and when you reach it, again you move to a random position, and here it resets, because here when you reach the random position earlier, it was set to true. So this will be true because this side is true. Basically Boolean math. If this is false and this is true, so reset the random target again to a new random target, move to it, and when you reach it, change to chase again, go here. It's all commented, you should look at it, and you can also see it happening live. You see, the ship rotates to a random position, and it goes to it. And when it reaches it, it will, yeah, that one is for here, it rotates back, and now it's going to chase some target. Let's see. No, this one. So, yeah, or that one. Oh, got destroyed. So this one is chasing some target. And that one is probably moving to a random position. And yeah, that one was chasing me. Now it moves to a random position. And now it's going to change to chase. Exploded. Yeah, it happens in a fight. This one is moving to a random position. I'm going to get destroyed in a moment. And now it reached that random position and it chases me again as its target. And again, when it comes too close, it moves to a random position again somewhere and chases again. And now it moves to another random position and gets destroyed. Yeah, that's how the movement script works. I hope it was clear. If it wasn't clear, ask me about it. In the future, I'm going to refactor it and put each behavior in its own method on a different file. I'll call it AI behavior or just AI. So it will be only one line of code instead of all of that. Yeah, and that's it for this video.